Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 53 in our incredible tutorial series where you are learning artificial intelligence on the Jetson Nano. I'm going to need you to pour yourself an enormous mug of iced coffee, and I'm going to need you to get ready to learn some cool new stuff. So let's go ahead and let's get out our Jetson Nano gear. And as you're getting out your gear, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It's an encouragement to me, and it's a help, and it's your help and encouragement that keeps this great content coming. You guys that are not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and talk about what we are going to learn today. What we are going to learn is we're going to learn how to do object detection and object recognition. And this is where we're really getting into the machine learning and the deep neural networks. This is where we're really getting into the heart of artificial intelligence. Now, last week we did image recognition. And the obvious question is, what is the difference between image recognition and object detection? Well, image recognition is where if you show the computer something, like I have a nice little teapot here. If I show it the teapot, it knows that it's a teapot. But image recognition really works in the context of like showing it a very clear picture. Like right now you see there's a microphone, there's all this stuff, my face in the background. You would sort of give it more like a really clear picture with nothing else in it, where it sees obviously what you're showing it, and then it tells you what object that you have put there. Now that is neat and that is exciting, and we had some fun with that last week. Okay, we had some fun with that last week, but what we're going to do this week is we're going to go beyond that to something much more powerful, and that is object detection. And the way object detection is, you look at a much more complex scene, like you point the camera at the room, and looking at this very general case, it goes in and it picks out things that it recognizes in the room. And so actually object detection is quite a bit harder because it's a much more complicated problem. Also, it's detecting more than one object at once. One object might be kind of partially in front of the other object. Can get kind of complicated. The other thing that that object detection does, that image recognition does not do, object detection not only recognizes the object, but then detects where it is. So it gives you a location of it, to where image recognition just said, okay, I see a teapot. Object detection would say, I see a teapot and it's at this location and that location. So really quite a bit more complicated. Also, I should probably get out of your way, so I will get out of your way here. But let's kind of go in and look also at something that's really important. I did a search on Hello AI World, and this first response back is Dusty-NVIDIA NV Jetson Inference Hello AI World. So we're going to that NVIDIA Hello AI World page on GitHub. And if we scroll down towards the bottom, we can see these two things that we are doing. We are doing image recognition, which we did last week, and you can use different pre-trained models. And I believe we were having the most luck with GoogleNet, okay? I hope you played around with different ones of these models, okay? But remember, when I had you install those Jetson Utilities and Jetson Inference Library, I had you install all of these. So you can play around with the different models. It's just that it's that detection setup, that Jetson Inference, where you're loading that library, that you specify which one of these that you're using. Okay, in today's lesson, we're not going to be using an image recognition model. We are going to be using an object detection model, and you have all of these different object detection models. You can play around with different ones. I think we're using one of the MobileNet ones today, but don't use an image recognition library to do object detection, and don't use an object detection library to do image recognition. Also, it's this column here. This is the key word you use in your program to get it. It gives you these other descriptors, but it's the center column. And similarly, over here on object detection, we need to use one of these in the second column if we want it to work right. Okay, enough of this introductory nonsense. Let's jump over here and get ready to learn some cool new stuff. So we are going to go ahead and open up Visual Studio Code, and then I believe we are working in the NVIDIA folder, and it looks like we've done 4 programs so far on deep learning. So we will come up and create a new one, which is going to be deep learning dash 5.py. That looks good. Okay, and we come up with a fresh new window here, fresh new program. I am going to move the file navigator out of the way so you have a nice clear view of what we're doing. Well, what do we need? We need to import, okay, we need to import Jetson.Inference. Okay, that's the library that's going to let us do the object detection. And as always, or at least as we did last week, we are going to import Jetson Utilities. The Jetson Utilities really allow you to either work with the camera, work with the display, or do some conversions. And so we'll get both of those libraries. We like to do frames per second, and so we need to import the time library. Our old friend CV2 is always a good one to have. Okay, now we will be doing a frames per second in our loop, and so we need to go ahead and we need to set up that timestamp to take our first measurement. Timestamp is equal to time.time. And so this is just grabbing a time of where we started the program, and then it'll begin doing it in the loop. We also are going to calculate frames per second filtered, so we need to start that with a value so it doesn't die the first time through, and we'll just set that as 0. All right, now this is the important one. We're going to set up our inference, set up our inference network. So we're going to call it net, and that is going to be equal to Jetson.Inference.detect net. And now we've got to tell it what detection network we are using. I'm going to use SSD dash mobile net dash v2, and I think I just showed those to you, right? And so I am using this SSD mobile net version 2. All right, so that will look good. And then we need to give it a threshold. I've got to turn this thing off or it's going to keep beeping. I am sorry about that. Okay, now we've got to give it a threshold value. Like, how do you say whether you found something or that? Well, you need to have, like, let's say a 50% confidence level. So we will say and that needs to be outside. That needs to be outside the quote. Okay, and so we're going to say threshold is equal to 0.5. All right, now we need to tell it the display width we want, so we will say display width, and I got that wrong. Got an extra parentheses. Let me close this parenthesis over here. That looks good. Display width, we will make 1280. Okay, display height is equal to 720. Okay, and now we're going to say cam is equal to Jetson.utils.gst. That's like GStreamer camera, I believe is what that stands for. Jetson.utils GST camera. And now we've got to tell it the display width that we want, the display height that we want, And then for the Raspberry Pi camera, we just put in single quotes 0. All right. Now for you home gamers that are using the, we'll copy this and paste it. If you are using a webcam instead of the Raspberry Pi camera, I do believe you would want to put /dev/video1. And it's very important to spell video right, okay? So I think that we'll just go ahead and we will start with, we are going to start with using the webcam, so I'll just comment out, I'll comment out the Raspberry Pi camera. Remind me to come back and make sure that it works with both of them, just to make sure that our code is good. Okay, now we have set up the camera. Now we need to set up the display. Display is equal to jetson.utils.glDisplay. Okay, and this will just set up whatever display you're using. All right, it'll just use the display that you're using. So this could not get much simpler. So now we need to start doing the stuff, the real stuff. So we're going to create a while loop while display dot is open. While display is open, we're going to open close, and then this will be a loop that needs to be outside. Okay, while display is open. And now what are we going to do? Well, we're going to grab our image. So img, we're also going to grab width, and we're also going to grab height, and that's going to be equal to cam.capture RGBA. Okay, and open close. All right, so we're using the Jetson utility to grab the frame, to do the object detection, and then to display the results. Now what we're going to see is that you can do the grabbing the frame with OpenCV and you can do the displaying with OpenCV, but we're doing the simplest possible program to begin with. Okay, that all looks good. Now we are going to do a display dot render once. Why is it display? Because that's what we named the display object up here. If I'd called it screen, then I would call it screen here. What are we going to do? We're going to render once. So that's kind of like the IM show in OpenCV. And then we are going to do img, comma, width, comma, height, HEIGHT. Okay. So we are going to render once our image that we got, width and height. Okay, now we're going to calculate our frames per second. So we're going to say dt, that's change in time, is equal to time dot time, that's the present time, minus timestamp, which we set up at the top of the program. We already have that. And now we need to go ahead and grab timestamp for the next time around because we're looking for elapsed time. So we've got to get the timestamp that we're going to use the next time through the loop. So we're going to say timestamp is going to be equal to time dot time, the present time. Now, how much time elapsed since the last time through the loop and the present time through the loop? Well, that would be dt, and that's going to be equal to time dot, I already did that, I'm sorry. I already did that. So frames per second FPS is equal to 1 over dt. So like if it takes 1/10 of a second to go through the loop, how many times can you go through the loop a second? 10 times. So it's 1 over whatever that elapsed time is. And then because this can be all over the place, we are going to low pass filter it. And the way we do that, as per before, we say frames per second FPS filtered is equal to 0.9 times whatever we had before, frames per second filtered, plus 0.1 times whatever our latest reading is. And what this means is we don't trust a new reading. We kind of gradually change over time, and it takes all the noise out of your data. Low pass filter, very, very powerful tool. Okay, now what we're going to do is we're going to go ahead and print and let's round it off. So I'm going to take I'm going to make a string, and I'm going to round. I don't think I need to make a string. I think I can just print round. No, I need to make a string. Okay, string of round. So we're going to round off what? Frames per second. And how many places do we want to round it to? 1. So we just have 1 decimal point. Okay, and then we close the 2 parentheses, and then we concatenate with that string. The plus just adds a string to the end of a string. We're going to concatenate what the label space FPS. All right, guys, what is the chance that this thing is going to run? I've been doing a lot of typing here. Let's right mouse click. Let's run Python file in terminal, and let's see what happens. Whoa, right off the bat. Built-in network was requested. What is this nonsense? I misspelled mobile net. Were you guys yelling at me? Mobile net. It's mobile net. All right. That was a horrible mistake. Made it further than we did the first time. Loading the Coco UFF. That's a big milestone. Okay, let's see what's happening. We got a lot of stuff happening. Okay, boom. All right, let's take a look. Here's the camera, and it died. What did it not like? Didn't like frames per second. Oh, okay. Here I said frames per second filled where it was an uppercase F. Did you guys catch that? That was a typo. All right. Right mouse click. And I'll have my camera at the ready this time. Run type Python file in terminal. Okay, let's see. I'll get some stuff going here. Okay, it is loading. Trying to get some stuff here ready for you to look at. Okay. Now, it froze up on me, so that's not good. And so let's see if we can figure out what happened. Man, this thing is frozen hard. Let's see. Let's see if I can. Okay, that was really frozen hard. What did it not like? Still didn't like frames per second filled. I'm having problems here. Okay. Frames per second is 1 over dt. Frames per second FILT is 0.9 times frames per second filled. What is this not liking? Line 20. Do I still have a typo here? FPS filled. FPS filled. I said filtered up here, and it should have been FTS filled like that. Okay, let's try it again. Taking me a second to get in my coding zone here. Got the camera ready to show it something if it pops up. Looks like it is still running down there and still pretty happy. Okay, we got something happening here, but not a whole lot. Okay. It is not really doing anything. And so what did I do wrong? Okay, we got the camera working, but it's not actually doing any detection. Okay, let's look. It's printing the frames per second. That's good. But it didn't actually do any... we forgot the most important thing. We never actually did the detection. So detections, okay, is equal to net.detect. And then what are we going to detect? IMG, comma, width, comma, height. All right, so 3 things. You grab the frame, you analyze the frame, and then you show your results of the frame with your analysis. So we grab the frame, we do the detection, and then we display it with the render once command. So it's sort of like grab, analyze, show, grab, analyze, show. This time I feel like this is really going to work. And it looked like we're operating at about 10 frames per second, and that is not too shabby. So let's see what happens here. second for these things to load. Okay. All right. Look at that. Shazam. Look at that. It found the keyboard. It sees 2 keyboards. Let's see. Yeah, I have a lot of keyboards going here. 3 keyboards. Look at that. And then it sees 2 mice and a keyboard. Let's see if it can do the camera. It's having a little trouble with the camera. It sees the cup. Okay, it's interpreting the monitor as a TV. That kind of makes sense. Let's look up here, and it sees the umbrella. It sees my lighting as an umbrella. If I look over there, it sees a chair. Okay, and then let's see if it'll see that desk. My desk has so much jump on it. It sees the stack of books. It sees the computer screens out there. It sees the chairs out there. Let's see. I'm not sure. I thought it should be able to do this camera, but let's see if we can give it a better view of the camera. It might be that this model that I'm using doesn't know the camera, but you can see the cup, the keyboard. Let's see if we can give it a little different view there. Let's see if we pointed at the Jetson Nano. It thinks it's a motorcycle. The Jetson Nano thinks itself as a motorcycle. The Jetson Nano dreams of one day being a motorcycle. Okay, so let's see here. We've got cup. It sees my coffee, and it sees the keyboard. Let's see if it'll do a pen. Okay, it thinks it's a knife. All right, so not doing very well on the pen. But what's just amazing is all the things that it can find when you put it out there. You see, it sees the books, it sees the TVs in the background, so it can pick things out of a very complicated scene. Umbrella. You see, it sees the umbrellas and the chairs at the same time. So that is pretty darn cool. Okay, guys. That is really, really something neat. But now let me click out of this. So what do I love here? I love that in about 15 minutes of code, we're doing deep neural networks. We are running a pre-trained deep neural network, and we're finding things, and we're doing it at 10 frames a second. So that is really, really, really exciting. What do I not like so much about this? Well, really, all we did was make 3 library calls to already written Jetson, NVIDIA Jetson libraries. But if you look at this, I really don't have any parameters to play with. And let me show you like one thing, like just even really simple things. Let me show you something really simple. Run it again. They're not giving us any handles, any parameters. It's sort of like grab the frame, analyze the frame, and show the frames, and we're not having any parameters or any hooks into the program to control exactly how it does it. Okay, so do you see there that it turns the it opens up this window? Okay, we don't have any ability to control how big that window is. That window just comes out full screen, whatever your screen is. Oh, well, you can go in and resize it. Well, let's see if I come in and resize the window. Well, what it does is it crops the top part off, and it doesn't give me any scroll bars. And so right off the bat, I see that what they are doing here, no offense to them, but it's kind of like, let's make it simple so people will understand it, but then they make it so simple that they don't give us any ability to do anything with it on our own. So if we came in and on this display render once, absolutely no ability. This width and height is the width of the frame. It's not the width of the window, so they didn't give us any ability to control that. So we're going to say that this command here is totally useless beyond the simple demonstration. Also, the problem is similarly with this image capture, just about as useless. All right, and so what is very, very useful is this. This was useless. What was very useful was this one command where it goes in and does the detection. That is the thing that is really, really useful. So what we need to do is we need to go back and take the strategy that we kind of ended up with in, what was it, about lesson number 50, where we're going to grab the frame using OpenCV, we're going to convert it using CUDA from NumPy, and then we're going to do the detections here with the Jetson utility, the net.detect, and then we're going to display it using OpenCV. So we're going to go in and we are going to work on this program to make it better. But I want to save this where it is, so let's go ahead and I'm just going to save it as Deep Learning 6 now, or I'm going to start a new program, Deep Learning 6, so I can do that by doing a save as. And I will call this one Deep Learning 6, all right, and save. And now I will be editing Deep Learning 6, but we're not going to lose our Deep Learning 5. Okay, so let's go in and let's see if we can make this thing where we can actually start doing something. Because, like, if we're going to start doing things on our own, I need to know where the objects are, and I need to know what they are, and then I need to be doing things. But if you look at this program, it didn't even return to us positions. It sort of passed the parameters from one of its routines to another one, and it kind of cut us out of the loop. So we got to bust into this thing. Okay, so let's come up to the top and see what we need to do. And I think right off the bat, we still need Jetson Inference, Jetson Utilities, because we are going to be doing the detection and a conversion. We're going to need time and OpenCV. We're also going to need import NumPy. Okay, we will need NumPy, and we need to import NumPy as NP. And like that. Okay, we'll still do our timestamp and our frames per second filtered, and we are still going to do our detection network. Okay, we're still going to do our detection network because we'll need to do that. All right, now we have the display width, we have the display height. Now also, because we might want to use the Raspberry Pi camera, and we might want to use that long GStreamer launch string, so that's going to want to know the flip method. So we're going to say flip is 2 because my camera needs a flip 2 to make it right side up. Yours might not, depending on how you have it mounted. And then also, since we're going to be doing OpenCV and we're going to be labeling our image, we need to go ahead and set up a font. So we're going to say font is equal to cv2 dot font underscore Hershey underscore simplex. You guys notice how I kind of, in one of the earlier lessons, I fixed that autocomplete thing, but it still seems to get confused. Like sometimes it's not doing the OpenCV autocomplete, and you got to kill the program, and then you got to start it again, and then it seems to do the IntelliSense or the autocomplete for a little while, but it's still not working perfectly. So I am greatly disappointed with that. Okay, so we have set up our font. Okay, now we need to do the GStreamer code for launching the camera. And the easiest way to do that is go to the most excellent www.toptechboy.com and come back to our last lesson, AI on the Jetson Nano, lesson 52. And remember how we came up with that optimized string that really sets up a very clear image from the Raspberry Pi camera, really high image quality. Well, we need to get that here, and it's just this line of code. So we will click on the two little pages, right mouse click copy. And then we are going to come back over here, right mouse click paste, and now we have that really good GStreamer string. Okay, and now after that we need to go ahead and set up the camera. So we will say cam is equal to cv2 dot video capture, and then we will do that on cam set like that. All right, so that is if you're using the Raspberry Pi camera. All right. Now, and that was if we were using the Raspberry Pi camera on the earlier program. Okay. And I just comment that out. Now, we are not going to be using the Jetson utility to do the camera, so we're going to comment out that line. I'm going to leave it in because if we want to switch back and forth, we can always comment it out. And then we are not going to be using the Jetson utilities for the display, so we're going to comment that out. Okay, does that make sense? I hope it does. But now with those commented out, we've got to come in, and now we have to put in right here the setup if we're going to use the webcam with this. And so we would say cam here would be equal to cv2 dot video capture. Okay, and now we are going to use /dev /vido1 should be the webcam. All right, now remember that remember this business down here, this detection, this net.detect, it's going to want the width and height. Well, we set the width and height here, but that's kind of like what we're asking the camera for, but do we really know that that is what we got? So what we need to do is we need to make sure that, you know, I guess what I'm saying is, in the Raspberry Pi camera, we send those parameters, but we just simply launched the webcam, so we need to explicitly tell it that. So we're going to say cam.set, and what are we going to do? cv2.cap underscore prop underscore frame underscore width, and we're going to set that to our display width from above. Now I think the easiest thing is to copy this and then paste it, and this time we are going to set cap prop frame height. Okay, and then this will be display height, like that. So now what we're going to do is we either need to comment out these three, or we need to comment out these two. Okay, I think I'll use the webcam, so I'm going to comment out the Raspberry Pi cam. If I remember, we'll come back and try it with both. Okay, so now we have set those things, so that is good. And now we're going to let's see. Let me think here a second. I just want to make sure that we have all of our setup bookkeeping done. All right. Now, since we're not using the Jetson display, we can't use while display is open because we're not using that anymore. So we're going to comment that out. I'm just going to comment things out rather than erase them. And so we're going to say while what? Our old while true. While true. When is true true? I think it wants an uppercase true. While true. Okay. When is true true? True is always true. So we're creating an infinite loop. Okay. Now what we are going to do is we are not going to read it using the Jetson utility, the cam.capture RGBA. We are going to go back to our old friend, underscore, comma, and then what are we going to get? We are going to get image, img, and that is going to be equal to cam.read, our old OpenCV command for reading the camera. All right, so now good news is we have the image. But while we ask for a very specific size, we better ask what size we have, because this detections, if you don't use the right width and height, you're going to get a crash. You got to make sure that you're sending it not what you asked for, but what you actually have. And so you can say height is equal to img.shape, and it is height is the 0th element of that array, and that should be like this. Height is the 0th element, and then width is equal to img.shape, and it is the first element. And so if you do an IMG shape, it takes your image and it tells you the height comma width. And so we're breaking that little array up into the two things we want, height and width. All right, so we have that. That is very useful. Now, this is the problem, and this is what we talked about last week. Our problem is that that image that comes from OpenCV is a blue, green, red image with a depth of 3 and like an 8-bit integer numbers. Okay, so it's an 8-bit integer, depth of 3, and that is not what net.detect wants. So we have to do a conversion. And remember that for conversion is first we've got to go to RGBA from BGR. And so we're going to do and we're going to create a new image. You see, I want to create this image because I'll use this image to display down in the IM show. And so I don't want to convert to and then have to convert from. And so I'm going to keep IMG because I'll use it later, and I'll create a new variable which I will call frame, and that is equal to CV2 dot CVT color with an uppercase C, and then IMG dot CV2 dot, and now I'm going to do the conversion. That was not right. Okay, what am I going to convert? I'm going to make frame a new variable, a new picture out of image by converting the color. And then how am I going to do the color conversion? Well, CV2 dot color underscore BGR to RGBA, because our friend Mr. Net.detect wants an RGBA. All right, now it's worse than that. After the parenthesis, you have to give it the type of numbers it's going to be. So it's going to be as type, and then it's going to be np.float 32. So it's a 32-bit floating point number, which is the number that tells you what the color strength is in each position, as opposed to a simple, like I believe it's an 8-bit unsigned int that OpenCV uses. So this should give us the right array now. Okay, but the problem is it's up here in the normal memory, and we need it down in the CUDA. We need it in the CUDA core, so we've got to do that conversion to a CUDA array. So now we made frame out of image, but now we're just going to still use frame. We're just going to change it, and what we're going to do is jetson.utils.CUDA from NumPy, and we want to do that on what? Frame. Okay, so we're going to take image, we're going to turn it into frame that's going to be an RGBA float 32 type of array, and now we're going to take that and we're going to change it into a CUDA array. And now frame should be something that the detection program now is going to be happy with. Okay, it's going to be happy with it. Now, I guess we got to do something. We get this detections thing back, but it's going to be pretty complicated because it has like all the locations and all the names of everything you find. And so we're going to have to figure out what to do with that. And so I'm just going to try print detections. And it's probably going to be like an array. It's going to be an array of some type that has a lot of information in it. But let's just look at it first. Print detections. That looks pretty good. Okay. And now let me see. What else do we want to do? Okay, we're going to print detections. And now we are going to do our frames per second, all of that kind of good stuff. All right. And now what we are going to do is we are going to have to clean up the program now. Like we have to do a what I want to do is I want to put a label on the frame now of how fast we're going, the frames per second. So let's go ahead and do that. And this is always the command that I mess up on more than any other command, and that is our old friend our old friend, and I'm not going to print frames per second because I'm going to display it, so I'll take that out. I'm not going to print frames per second. I'm going to display it with our old friend CV2 dot put text, and then we are going to put it on image. Remember, that is our original image that is in the OpenCV format, not frame, which is in that CUDA format that the Jetson Detect wants. So IMG, we're going to put on that, and then the string of the round of the frames per second filtered, which we just calculated, and we're going to round it to 1. Okay, and then we are going to come over outside of those two parentheses, but before the end of the first parenthesis. Okay, and then we're going to concatenate with that string the label, so I'm going to put a quote space frames per second. So that is a label that is going to be concatenated with the string value of the rounded value of frames per second filtered. All right, now we have to tell it where we want it, and that's a tuple 0, 30. So we want to go over 0 but come down 30, so the label is on the picture and not half off the picture. Now we got to scoot over from that, and we got to tell it the font, which we defined above, and then we want a height, like a text height of about 1. And now what color? Well, let's go red, which is 0, 0, 255. Ooh, not 0, 0, 0, 255, and all that 0, 0, 255 is all inside of quotes. And then let's give it a weight of 2. Okay, and now let's go ahead and show our frame. cv2.im show, and then what are we going to show? My detect cam. And then what is it? It is IMG, because that is the original image, not the one that we converted. Okay, and then let's be good and let's go ahead and do a cv2.move window, and then we are going to move the window detect cam. And then where are we going to move it? We are going to move it to 0, 0. 0, 0 will be in the upper left of our screen. So now we have that done. Now we got to clean up for a clean kill. We got to have a clean kill when we do this. And so now we will kind of take care of all that stuff, which will be if cv2.wait key for 1 millisecond, we'll wait for 1 millisecond. If that's equal ORD, the ordinance of Q. So that's saying if the wait key sees the Q press, then we are going to put a colon here at the end of the if statement. What are we going to do? We are going to break, and then we'll come all the way back, unindent all the way, and say cam.release to let that camera go. And then we are going to say cv2.destroy all windows, open, close. Okay, so now we are grabbing the image with OpenCV. We're converting it to the CUDA type array that's used by the image, the object detection program, and then we're displaying things with the original image, the OpenCV. Now this isn't going to label that image at all. That's not going to label the frame, but we're just seeing if the program runs at this point, and then it's going to print out. The one thing it's going to do is it's going to print out the detections, so we can just at least sort of see how the data is coming to us. So let's run Python file in terminal. Hasn't crashed yet. Maybe that's a good thing. You know, this model takes a little while to load. Okay. Ooh, line 36. What is this nonsense? Oh, did you guys see this? I need to do the detections not on IMG. On what? Frame. Okay. I need to do it on frame. I went to all that work to create frame and then I didn't use it. So let's try it again. Okay. doing some stuff here. Ooh. What is it not like this time? Line 38. Display render once. Oh, yeah. We don't want to do that. Remember, we're not doing this display anymore. Okay, we should have commented that out where we didn't create the display, and so it certainly is not going to be able to do that. So we're going to right mouse click. Remember, that was the old Jetson utility method of displaying the results, and we're using OpenCV, so we should have commented that out. Okay. Looks like it is moving along. Are you guys seeing this? The trade-off I have. Oh, all right. Now let's see what happens here. Okay, so the camera's working. Now you see our frames per second of 10 frames per second. That's what we want to see. Okay, but now let's see. We ask it to print out that detections array. Man, this thing is not wanting to focus here, huh? Wow. My webcam is not behaving very well. Okay, but usually it's such a well-behaved webcam. I'm not sure why it's not wanting to focus, but I'll not worry about that right now, because the real issue is what we want to see is what did it print out. Okay, and let's see here. This is showing the results of the conversion, and then it's saying Jetson Inference Detect Net dot detection object at, and then we got this strange thing. And so what that's saying is this detection object that it's passing back to us is like a complicated data structure that a simple print can't parse it. So it might be like arrays inside of arrays inside of arrays. And so that is not going to give us any useful information. And so what we know is that on that detections, it detects lots of different things. So it'll be sort of like an array and a comma and an array and a comma. And so I think instead of doing print.detections, we need to do a for loop where we try to step through that returned object. And so this is just kind of a guess, but I think that what I can do is say for detect, that would be like one object in this list of objects for detect in detections. Detections is that complicated object that was returned. I'm going to step through it and look at it object by object for detect in detections. And let me see here. For detect in detections, now let me just see if I just print detect. So that's like the one array or the one item inside of that complicated object that it's sending back to me. So let's see if I can kind of get in and start looking at the data by doing this. All right. Let's right mouse click. Let's run file in terminal. All right. Whoa, print detect. What is this? Old school. I'm still doing Python 2.7. I was very slow to upgrade to Python 3, but you got to use the parentheses in your print statements. I do like Python 3 now that I finally moved to it like 5 years after everyone else did. Okay, so I seem to have something going here. And it looks like it's going to focus this time. All right, so what I'm going to do is just give it something to look at. Like I'm going to see if I can give it a couple of things to look at there and then quit out of it. Now let's see. I am getting some results. Now look at this. So it looks like it found two objects, an object of class 76 and an object of class 74. And then it is telling me how confident it is. It's 92% confident, 99% confident. And so if I were going to guess, this is probably the keyboard and this is probably the mouse. But you notice it doesn't return to you keyboard and mouse. It returns to you like this is an ID. This is an ID, class ID 76 and class ID 74. Not too useful, but don't worry, we will get to the bottom of it. But what do I really like? I really like that it is giving me the top left of the item it found and the bottom right of the item it found. Now it's also giving me the center and the area and a bunch of other stuff, but really for me to do my magic in OpenCV, I want the top left, I want the bottom right, and I want to know what it is that it found. Okay, so let's see if we can get to the bottom of that. And so I think we've got to now bust up. Oh, and it tells me the center. That's kind of neat. Does this make sense? Yeah, the center would be between the top and the... Okay, so this makes sense. But we got to kind of bust this up so that we have information that we can actually use. And so we need to do that inside of our for loop. Where did our for loop go? There. And so now we don't want to print detect. We just did that to sort of see what it was. All right. But now we need to try to get that information out of that list. And so what do I want? Well, I want top. And the way you do this is you say top is that, or the first thing I want is the ID. So ID is going to be equal to, what did we call our object? Oh, it's detect. Okay, the object, we're stepping through detections and we're finding each detect inside of detections. So what I want is detect dot class ID, because this is probably returning from a class, an object from a class, and so I should be, this is probably the tag and this is probably the value. So if I say ID is equal to detect dot class ID, that should give me the ID. Okay, so now if we run this, we should see like a bunch of 74s and 76s, I think, if I'm parsing this right. I'm just kind of guessing. Okay, we'll run it and see what happens. So what we should see is the two things that it's finding, a keyboard and a mouse. Okay, so I've got the keyboard and the mouse. I got to get this over this. Let it see the keyboard and the mouse, and then I'll Q. Okay, and then let's come and see what was printed out. Okay. Was it finding anything? I said, oh, I said ID is equal to, let's say, print ID. So it was probably finding it. Good thing is it didn't crash. Now it should be printing out like 74s and 76s or whatever. All right, let's give it something to look at. Let's take some coffee. Notice I'm drinking hot coffee and cold coffee today. Okay, so now there we go. Give it something to look at. Let's quit out of it. Now let's come down and see if it found anything. Oh yeah, look. You see it found a 74 and a 76. It found a 74 and a 76. Okay. So now the $1,000,000 question is, what is a 74 and what is a 76? Well, luckily, there is, we can say the item, the name of the item is equal to what is the name of the item that is 76 and the name of the item that is 74. So we're going to say item is equal to net, that is that network that we created, dot a very useful command, get class description of what? Of ID. Okay, I just found ID. And now I want the name that goes with ID, so I use my net object, and it is get class description, and I put that in the variable item, and now let's print item. All right, now I think it should say keyboard and mouse. I really think it should. I am very confident. I'm not even going to hold my breath this time. You notice we don't hold our breath so much anymore since these things take so long to get loaded. Okay, so there we go. There we go. Now I'm going to quit out of it. Boom! Look at that. It found a keyboard, it found a person, and it found a mouse. Where was the person? Just seeing my hand, it grabbed my hand as a person, and it found the the mouse and the keyboard. Shazam! All right, we're busting this thing up, man. We're going to get some stuff that we can really do things with. Okay, so now I know what things are, right? And I know where they are. But let's go ahead and bust out those things. And I don't need to print these out anymore. I'll go ahead and print them. That's right. So I've got the ID. What else do I care about? I want top is equal to detect.top, uppercase, and then top left is going to be equal to, what did I do? I hit something strange on the keyboard. You guys let me know, can you see this font size well enough? If I make it bigger, it's easier for you to see, but there's more stuff running off the end of the page. Give me feedback about if this is about the right size, if you would like it bigger or smaller. Okay, so now left, oh man. Let me get back up here. Okay, left is equal to detect.left with an uppercase L, and I need a T on the left. All right, and now top left bottom is equal to detect.bottom, and then right is equal to detect.right. Okay, so now I'm going to print the item and then where it is. And so that would be top, left, bottom, right. Could it really be that easy? Could it really be that easy? Run Python file in terminal. Okay, confident I'm going to get the camera at the ready, just in case. What happened? Oh, misspelled right. Did you guys catch that? Right. Some of this is my keyboard. Some of this is my wireless keyboard not working perfectly. If you were smart, anytime you did video lessons on YouTube, you would use a wired internet connection and you would use a wired keyboard. But I live dangerously. Okay, let's try it again. That is really good coffee. Hey, you guys that are sending me coffee, thank you. I just got some very nice coffee from a young man. Very, very much appreciated it. Shazam, look at that. So now let's quit. Okay, let's see what we found here. A keyboard is at 7, top, left, bottom, right, and a mouse. Okay, it found the keyboard and the mouse. All right, guys. That is really slick. Okay, that is really slick. All right, this has been a little bit of a long lesson, so I'm going to go ahead and give you your homework now. What your homework now is to take the image, not the frame, but remember, take the image. The only thing we use frame for is to do the detections. Now you're with image. And I want you to go in and I want you to box everything that it finds and label everything that it finds. Okay, kind of like that original program. Let's come back here. Okay, let's go back to where we were. That was Deep Learning 5, right? Let's try. Let's run this again. Okay, there you go. Mouse and keyboard, and let's see. Yeah, you see the hand. It sees the hand as a person. Okay, that's kind of neat. Okay, so you don't have to make shaded boxes like this. I'm not sure how to do that in OpenCV, but I want you to draw a box around the items that are found, and then I want you to label them. Okay, now, yeah, is this really cool what they did? Yes, it was, but the problem is you have absolutely no control over it, absolutely no control at all over it. So if you want to do something, like imagine you wanted a robot to do something, or you wanted to move something, or you wanted to follow something, you can't, because that demonstration, all it does is allow you to grab a frame analyze it and show a frame, you can't get in there and start working with the numbers. So it doesn't look like a huge thing that we are doing with what we did in today's lesson, but it's the difference between just running someone else's demo and you being able to go out and understand how to write your own programs to start doing some really neat and some really cool stuff. All right, guys, I really hope you're having as much fun as I am. I hope you're having as much fun watching these things as I'm having making them. And guys, I've got some really exciting stuff coming up here in the next few lessons. And man, 53 lessons. We've also learned a lot. You guys also think about kind of following along some of my Jetson Xavier NX lessons, because on those, the early ones are going to be a little bit of a repeat of some of the stuff you learned in these early lessons, but then I'm going to be going faster further on that set of lessons. So you guys that have made it to this point in the Jetson Nano series, you might enjoy the Jetson Xavier NX lessons, because those will also run on the Jetson Nano. But I'll just be doing some stuff there that I haven't done on this series of lessons. And so you might kind of at least check out the video titles coming out there and see if there's anything that you want to do. All right, guys, really, again, really appreciate you tuning in and sticking with us. If you like it, think about giving us a thumbs up. Think about subscribing to the channel, hitting the bell so you'll get notifications on all my stuff that is coming out. And you guys, let's get more people involved. See if you can share these lessons. See, is there a young person in your neighborhood or a relative that you could start teaching this stuff to, that you could, kind of start passing on the stuff that you're learning to other people. I know a lot of dads are working with their kids. A lot of granddads are working with their kids. And that's what I really want. I want to get the younger generation involved in not just using technology, but knowing how to make technology, knowing how to create things. The world has enough users, the world needs more creators, and that's what I'm hoping to do with these series of lessons. Okay, guys, having a lot of fun. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.